Imagine trying to, craft that perfect visual scene
Yeah.
where every little element needs to be placed just so.
Right?
Maybe you're combining different objects or trying to move things around to match exactly what's in your head.
That's a common challenge.
And generative AI, well, it's come so far, hasn't it? Creating these amazing visuals. But often it just seems to lack that really fine-tuned control that artists need.
Yeah, that precise manipulation is often the missing piece.
It's almost like, having this incredible chef who makes masterpieces, but you can't actually tell them where to put the garnish.
That's a good way to put it.
So today we're taking a deep dive into a really fascinating new framework. It's called BlenderFusion.
Mm-hmm.
Our mission for you is to really unpack how this thing works, how it acts as a kind of shortcut to mastering complex visual compositing. It seems to bring together the best of, well, traditional 3D graphic software and the incredible power of modern generative AI.
And what's really compelling here, I think, is how it tackles that core challenge head on. It's
Yeah.
about bridging the gap between what you can imagine
Right.
and what generative models can actually produce with real fidelity and, crucially, control.
So it's not just pretty pictures.
No, not at all. This is about enabling a new level of highly controlled, 3D-aware scene creation, something that's been pretty tricky to get right with generative AI on its own.
Okay, so the big question then for visual artists listening is how do we get this amazing AI tech to actually listen to our precise instructions? BlenderFusion calls itself a generative visual compositing framework. How does this digital wizardry actually work, broadly speaking?
Well, it's designed cleverly. It sort of mirrors the traditional visual compositing workflow that people might already know,
Okay.
but it automates and enhances it quite a bit. It follows this really clear three-step pipeline. First up is layering.
Layering.
Yeah, that's where it takes visual inputs like images and turns them into 3D entities you can actually edit.
Yeah.
Then comes the editing phase. This is where you manipulate those 3D things with really granular control, and typically you do this inside 3D graphics software like Blender.
Makes sense.
And then finally, there's compositing. This step intelligently fuses everything back together into a coherent, photorealistic final scene, and it uses a generative model for that part.
So it's like a digital assembly line almost for images and videos. Each step is specialized. What really jumps out at me, though, is that you said it explicitly decouples the control from the generation. Why is that separation so important? What problem does that solve?
That decoupling, yeah, that's fundamental. It's really the key. You see, traditional generative models are fantastic at synthesis, right? Making new stuff.
Absolutely.
But they generally lack that precise 3D-aware control over individual bits of the scene. You can ask for a cat, sure, but telling that cat to, say, rotate exactly 45 degrees, move 3 feet left, and keep its appearance while the background stays put.
That's the hard part.
That's where they often struggle. You might get distortions, or the whole scene changes, you lose your composition. Now, graphics software like Blender gives you amazing control over 3D objects.
Total control.
But it doesn't have that inherent generative magic to create photorealism from scratch or blend things perfectly into a photo. So BlenderFusion, it combines these strengths. It gives you flexible, disentangled, 3D-aware manipulation precisely because it separates the what to generate from the how to control it.
Okay, I see. So you get the AI's creative power, but with the precision of a 3D editor.
Exactly, that's the goal.
All right, let's dive deeper into these stages. How does BlenderFusion even start this? Turning, say, a normal 2D photo into something it can actually edit in 3D.
Right, the layering process. It's quite clever. It uses what they call off-the-shelf visual foundation models, so tools that already exist.
Okay.
For instance, it might use something like SAM2, you can think of that like a digital scalpel. It's really good at finding and masking out individual objects in an image.
Ah, isolating them.
Precisely. And it also uses Depth Pro for metric depth predictions. This basically gives the AI 3D vision. It helps it understand how far away each pixel is from the camera. It gets the spatial layout.
So it understands the scene's depth.
It does. Then rough outlines like 2D bounding boxes get refined using another tool called grounding dyno, which helps pinpoint specific objects more accurately. And then these masks and the depth info, they're combined to create 3D point clouds and triangle meshes.
Wow.
This is the crucial step. They call it lifting. It takes the 2D objects from the photos and literally lifts them into 3D space. So they're not just flat cutouts anymore. They're actual 3D things you can manipulate.
And can it handle more than one image?
Oh, yes. It supports multiple input images. And if you need really high-quality 3D models for a specific task, it can optionally bring in more advanced models, like Hunyon 3D V2 for even better 3D shapes.
Okay, so now we have these objects lifted into 3D. Where does that vital control part happen? Where does the artist get their hands dirty?
That's the Blender-guided editing phase. This is where those lifted 3D objects get imported directly into Blender or potentially other similar 3D software.
Right, get to the familiar environment.
Exactly. And that's where the user gets all this versatile 3D-grounded modification power. Think of it like your digital workshop. You get fine-grained control over the basics, translation, so moving things around,
Moving object.
rotation, spinning them on any axis, scaling them up or down. You can even completely remove objects, insert new ones, or replace existing ones.
Standard 3D stuff, but applied here.
Pretty much. But it goes further. You can change specific attributes, an object's color, its material. You can even do non-rigid transformations.
Like bending or warping?
Yeah, deforming part of an object or controlling just one part of it. And you can insert totally new objects into the scene. Plus, you get full control over the virtual camera and the background, too. Simulating camera moves, swapping out backgrounds entirely. And the key thing is, all these operations are just inherited directly from Blender. That gives you that precise 3D control that purely generative models working in 2D just can't offer reliably. It's about telling a shoe, point that way, and having it actually do it without messing up.
So we've done all this careful 3D work, moved our objects, tweaked the angles in Blender. How does that precise 3D setup get turned back into a final image or video that looks, well, real? Photorealistic.
Right, that's the generative compositing step. This is where the realism really comes in. It uses a diffusion model, specifically one adapted from a strong pre-trained model like Stable Diffusion v2.1.
Or a powerful image generator.
A very powerful one. And it uses this interesting dual stream architecture. Picture two processes running side by side. One keeps looking at the original source scene to understand the context.
What was there before?
Exactly. And the other stream focuses on refining your edited target scene. This lets it compare the before and after and seamlessly integrate your changes without weird artifacts popping up. Its main job is to refine that rendered target view. It cleans up any small imperfections or glitches that might have crept in during the 3D reconstruction or the transformations you applied. And it's guided by lots of conditional inputs, things like the renderings from Blender, the masks for each object, the camera settings. They all work together to make sure the final output perfectly matches your edits and looks totally coherent and photorealistic.
That sounds incredibly complex to get right. Training a system to handle all those changes while maintaining that level of control, that must be a serious challenge. The paper mentions two key training strategies. Can you tell us a bit more about those?
Yes. Those two strategies are really the secret sauce here. They enable BlenderFusion's more advanced tricks. The first one is called source masking.
Source masking. Okay.
During training, what they do is randomly hide or mask out parts of the original source image and its 3D rendering. Why do this? Well, it teaches the model to effectively ignore the original content in areas that have been changed or replaced.
So it doesn't get confused by what used to be there.
Precisely. Imagine you remove a car from a street scene. Without this masking, the AI might try to fill that gap based on some faint ghost of the car.
Leading to weird blurs or outlines.
Exactly. Source masking forces it to create a plausible new background in that area as if the car was never there. It's really crucial for getting clean edits, especially with big changes like removing things, adding things, or changing the whole background. It stops the model relying too much on old, irrelevant info.
Okay, that makes sense. And the second strategy?
The second one is simulated object jittering. This sounds a bit funny, but it's simulating dynamic object motions while keeping the camera fixed during training.
Object jittering fixed camera. Why is that important?
It's subtle but critical. See, a lot of real-world video data used for training might show objects staying still while the camera moves around them.
Right, like orbiting an object.
Yeah. And that can lead to this problem called entangled motion control. The system learns that object appearance is tied to camera view, so it struggles to move an object independently without also unintentionally shifting the camera view or the background.
I see. It can't separate the two.
It struggles to. So by explicitly training the model with objects jittering, moving slightly back and forth, rotating a bit against a stable background, it gives the model vital practice, supervision, for disentangled control. It learns how to move objects cleanly on their own. So when you tell an object to move or rotate later, it does just that precisely without messing up the rest of the scene or the camera perspective.
It's like teaching it object permanence and independent motion.
That's a great way to think about it.
So what really strikes you about these strategies? They sound pretty ingenious for getting that specific kind of control.
Well, they're very cleverly designed to tackle those core limitations we see in generative models when you try to manipulate things precisely. They make sure the generative part, the compositor, actually follows the 3D edits you made and achieves that clean separation of elements. It's quite remarkable how they engineered these training scenarios that might not even be common in standard datasets, specifically to prepare the model for these complex, user-driven edits. It builds in a deeper understanding of how objects move independently in 3D space.
Which is what lets it make those clean edits you mentioned.
That's right. You can trust that only what you intended to change actually changes.
Okay, the paper shows some really impressive results. How does BlenderFusion actually perform compared to other methods out there for these kinds of complex editing jobs?
Yeah, the results are strong. BlenderFusion consistently performs better across the board, quantitatively speaking. It significantly outperforms older methods like Object 3D-IT and neural assets, especially in these complex compositional scene editing tasks.
So putting multiple objects together, moving them around.
Exactly. And you see improvements across different datasets, MoVE, Objectron, even the Waymo Open dataset, which is challenging autonomous driving data. The standard metrics they use, like PSNR, SM, FID, they all show BlenderFusion models both the foreground objects and the background more accurately. The images end up closer to the ground truth and just look more realistic overall.
But metrics are one thing. What does that superior performance actually look like? When we talk about disentangled control, what can you actually see in the results?
That's where it gets really clear. In practice, the difference is often night and day. For that disentangled control, BlenderFusion lets you, say, move an object, rotate it 90 degrees or 180, scale it up or down, all while the camera perspective stays locked.
So the background doesn't warp or shift.
Exactly. The background remains perfectly stable. Only the object you targeted moves or changes. You've probably seen other models struggle with this, right?
Oh, yeah.
Some baselines, like 3D-IT, the paper shows they often just fail on these disentangled tasks. They might keep the object frozen, or worse, move the whole scene along with it. That indicates that entanglement problem we talked about. Neural assets might do better at disentanglement, but can lose important details. The object's appearance or shape might degrade. BlenderFusion tends to maintain both the geometry and the appearance pretty well, while crucially respecting that fixed background.
Okay. And what about more complex edits?
Yeah.
Fine-grained stuff, multiple objects.
That's another area where it shines. For fine-grained editing, BlenderFusion maintains geometric and semantic consistency even with multi-object edits. Other methods might struggle, misaligning objects or mixing up their appearances if you try to edit several at once.
Right.
For example, if you ask it to duplicate an object multiple times, BlenderFusion tends to faithfully generate all the duplicates, keeping their original look and shape intact. Some baselines apparently might generate fewer than you asked for, say, only 5 cups instead of 8, or they might introduce weird changes to the copies. It also handles tricky things like shuffling objects around, swapping their positions, all while keeping the perspective shifts looking natural and maintaining consistent lighting across the whole scene. That consistency is a big challenge.
And it's not just the algorithms judging this, right? What did actual humans think when they compared the results?
The human evaluations were pretty decisive. Users overwhelmingly preferred BlenderFusion's outpoint. Overall, it got something like an 87% preference rating compared to only about 6% for the baselines.
Wow, that's a huge difference.
It is, and what's really telling is that the gap got even wider when the editing task was more difficult. For those really fine-grained control tasks we just discussed, the preference for BlenderFusion jumped to nearly 94%.
So the harder the task, the more its advantages showed.
Exactly. It really highlights the benefit of having that solid 3D foundation, especially when you need precise, complex edits.
So does this system only work on nice, clean lab data? Or can it actually cope with the messiness of real-world images? Weird lighting, cluttered scenes.
That's a fair question. It actually shows reasonable generalization, even when it's trained on simpler, more controlled data sets like Objectron.
Which has cleaner objects.
Right. It can still generalize reasonably well to complex, sort of in-the-wild images. Things from datasets like SUN-RGBD, ARCID scenes, HyperSim, which contain much more varied and realistic indoor scenes.
So it doesn't completely fall apart on new types of images.
No, it doesn't. Now, they do acknowledge there might be some degradation in visual quality compared to results on data it was specifically trained on. Maybe things aren't quite as sharp or the lighting isn't perfectly handled in very tricky situations. But the fact that it can work with such diverse real-world scenes is pretty significant.
Yeah, that suggests it's quite robust.
It suggests a solid foundation that goes beyond just controlled environments. For an artist, that could mean less time prepping source images and more time actually creating.
That's a really practical benefit. So
Yeah.
tying it all together, what does this mean for someone listening, maybe an artist, a designer, who wants to take their ideas and bring them to life with that kind of really granular control?
Well, it means they can potentially use a much more intuitive workflow, what they call progressive editing. You can make changes step by step inside Blender, your 3D software.
Take a tweak.
Make a tweak, and then immediately see the refined, photorealistic result from the generative compositor. It really inherits Blender's flexibility. So you could do things like specific color changes on just one part of an object. You could apply text details onto surfaces.
Putting a logo on something.
Exactly. Or deforming parts of an object, controlling things at a really fine part level, even swapping out textures seamlessly. This back and forth, this interactive process lets creators really sculpt their vision with a level of detail and control that comes directly from merging that powerful 3D engine with the generative AI.
You could almost prototype visual ideas very quickly.
Absolutely. Imagine designing, say, a product ad. You could photograph your product, then drop it into a totally different photorealistic scene, maybe a beach. Rotate it perfectly to catch the light, maybe change its color variant on the fly. All without needing expensive reshoots or hours of manual compositing.
Okay, this deep dive into BlenderFusion really does show the potential here. Combining those precise traditional 3D tools with the, frankly, amazing power of generative AI, it feels like it's not just about creating anymore, but about truly controlling the creation process. In a way, generative models alone haven't quite managed.
Right, and if you step back and look at the bigger picture, this kind of work really underscores something important about the future of visual content. It's maybe not about one technology completely replacing another.
The AI taking over everything.
Not necessarily. It seems more likely to be about intelligent integration, finding clever ways to blend these different strengths. And it does raise a fascinating question, doesn't it? How will this mix of explicit, precise control and powerful generative synthesis change what we even expect from digital creativity? What new possibilities does it open up?
You really have to consider what this means for visual artists, designers, anyone who wants to bring a very specific vision to life without being stuck with the sort of black box feel you sometimes get from generative tools.
Yeah.
This 3D-grounded approach, it could genuinely be a game changer for detailed scene building, for visual storytelling. It offers a level of freedom and efficiency that's pretty exciting. We hope this deep dive has given you some surprising facts and maybe some new insights into this really fast-moving world of generative visual editing.